I would like to welcome you all from all over the continent, and some of you even from different places in the world. So thank you for joining us. So today's presentation is presented by Dr. Girish. Brief introduction about Dr. Girish. He received his PhD in civil engineering from the University of Sherbrooke in Canada, in Quebec, and the Master's of Technology in Earthquake Engineering from the Institute of Technology in India. He received also, during his education, he received the University Gold Medal in 2013 for Bachelor of Technology project on strengthening of reinforced concrete columns with externally bonded fiber reinforced polymers from the Veer Surendra Sai University of Technology in India again. So his research interest included structural concrete reinforced with fiber reinforced polymers, testing and characterizations of fiber reinforced polymer materials, and nonlinear finite elements analysis of reinforced concrete structures. Girish is a senior structural researcher at SFTec in Montreal, Quebec, and a MITAX postdoctoral fellow at University of Sherbrooke in Canada. He's been working with SFTec for a little bit over a year, and he basically assisted us in designing and converting different structural projects from steel to GFRP. Some of the projects he worked on is shear walls, structural slabs, and retaining walls also. So this is just a few of the projects he worked on while working with us. Dr. Girish, the mic is yours.
Thank you, Rick, for the brief introduction. Today we are going to talk on the topic and introduction to fiber reinforced polymer RockBolt, and we are discussing our product SFT-RockBolt. So through this presentation, I will give a brief overview of the properties of the RockBolt, its application, and I will go through case studies to elaborate its present uses. So before going through the main presentation, a brief introduction about the SFTec. So our products are mostly designed in Canada and are manufactured in China by Sandog Safety Industries Co. Limited, who are specialized in the manufacturing of fiber reinforced polymer bars. We work with national and international engineering firms. We work with them through the design process and help them with the fiber reinforced polymer design standards, whether they are in Canada or in the United States. So we focus on the parking facilities, water treatment plants, and retaining walls. And our focus is mainly on the glass fiber bars and the carbon strips applications. The SFTec fiber reinforced polymer bar is made from composite materials, fiberglass or carbon fiber, and is manufactured by pultrusion process using a mix of recycled fibers and resins. And this figure is showing the microscopic view of the FRP bar. There are three different types of FRP bar: carbon, aramide, and glass fiber reinforced polymer bars are available in the market. And the stress strain plots show how these fiber reinforced polymer bars compared with the steel bar. And 2 points should be noted from this plot. First, the glass fiber reinforced polymer bar have low strength compared to the order two bar FRP bars. And the second, the strength of all the FRP bars are higher than that of the steel bar. However, this behavior, the behavior of the fiber reinforced polymer bar is linearly elastic up to the failure. So we can produce different types of fiber reinforced polymer products depending on the project's requirement. Some of the fiber reinforced polymer bars we produce are straight bars, spiral stirrers for transverse reinforcement, bent bars, and glass fiber reinforced polymer shear connectors. The glass fiber reinforced polymer bar is widely used due to its production cost and have better tensile strength compared to the other fiber reinforced polymer bars. Some of the advantages of the SFTec glass fiber reinforced polymer bar over the conventional steel bars are: it have longer service life because of its corrosion resistance, therefore improved durability in harsh environments such as construction near coastal areas in North American cold climates. The FRP bars have better resistance against corrosion compared to the steel bars. And as I told earlier, the tensile strength of FRP bars are 2 to 3 times more than that of the steel bar. However, it have more tensile strength. Fiber reinforced polymers bar are lighter due to low density compared to the steel bar. And due to the corrosion resistance, fiber reinforced polymer bar are good for harsh chemical environments such as well. And it is neutral to electric and magnetic disturbance, useful for applications such as airport, military applications, MRI rooms, and hospitals. So some of the selected field application of SFTec fiber reinforced polymer bar we have already done in Canada. Glass fiber reinforced polymer bar, reinforced concrete waffle floor slab designed with SFTec glass fiber reinforced polymer bar, which was built last year in Halifax, Nova Scotia. It can be used for glass slab on grades, and it is a non-structural slab, and it is a one-to-one replacement. Like whatever you use the steel design, you can same use for the GFRP reinforcement on GFRP slab on grade design. And it will save a lot of money compared to the steel bar in terms of labor and transportation. Another project saw the cast in situ precast sandwich panels, and they have used our glass fiber reinforced polymer bar in their project as reinforcement, and it was built in China. And in the right is a retaining wall built for the city of Montreal, and the retaining wall is designed to dump snow with de-icing salt during the winter. So they built this retaining wall with SFTec glass fiber reinforced polymer bar, which provide as resistance against the chemicals used in the de-icing salts. Now coming to our main topic, RockBolt. So before going to the presentation, let me define what is RockBolt. A RockBolt is a long anchor bolt for generally used for stabilizing rock excavation, and it is used in tunnels, mining, or rock cuts. So the RockBolt transfer the load, as we can see here, transfer the load from stable exterior to the confined, or you can say the much stronger interior of the rock mass. Like you can see there, the tunnel is a hollow section, and it's the RockBolt is connected to the rock mass to provide the stability to the upper rock masses. What are the present problems with the steel RockBolt? The problem of the corrosion and cracking, bolts in coal mines and other underground mines, and high variability of mine water corrosivity in mining industry. The use of high tensile steel for rock bolts and anchor bolts present a great incidence of corrosion, which is dangerous in underground environments. And in case of aggressive environment conditions, such as in coal mines, steel bolts corrodes in a matter of days than years. So as we can see here, RockBolt might be installed in a highly acidic or highly alkaline environment that promote accelerated corrosion. As seen in this figure, the RockBolt made of the steel generally corroded after the 2 months. Now, compared with the conventional steel RockBolt, a fiber reinforced polymer RockBolt has several advantages. For example, they have high tensile strength, relatively low shear strength, extremely low conductivity, durability, and most importantly, corrosion resistance. The fiber reinforced polymer RockBolts can be cut easily without creating any sparks, and therefore they are suitable in the coal mines. And finally, fiber reinforced polymer RockBolts can be useful in minings and underground projects. The SFTec RockBolt is a rock bolting system based on fully threaded solid glass fiber reinforced polymer bar, and it have a nominal diameter ranging from 16 millimeter to 27 millimeter, a nominal area of 200 to 580 square millimeter. It can carry an ultimate tensile load of 200 to 550 kilonewton and ultimate tensile strength of about 1000 megapascal. The RockBolts are employed in rock design to stabilize the rock mass during tunnel excavations. And in case of the rock mass moment, the bolt develop a restraining force that is transferred back to the rock mass as shown in this figure. And the driving force is countered in this way such that the total resistance mobilized within the rock mass is equal to the applied force. And in the second application, the RockBolts are a type of drilled soil nail used when the ground to be stabilized consists of rock materials. The bolt hold unstable joint or fracture rock masses together in compression with bearing face plates as shown in figure, providing passive resistance, forming a more stable structural entity. The RockBolt application is not only limited to the mining and tunneling industry. Now, in the present day, it is used in stabilizing rock cuts, steep slopes, bridges, abutments, and reinforced concrete dams also. Now, going through our first case study, the first case study is about the Vernia tunnel. The Vernia is a narrow gauge railway tunnel in eastern Switzerland and is an excellent example of use of permanent glass fiber reinforced polymer rock bolts in a demanding environment. And the construction of this tunnel was begun in 1991 and it came to operation in the year 1999. And with a burden ranging up to 1,500 meters and highly heterogeneous geology, many challenges for the tunnel excavation had to be overcome. The burdens were the rock burst as well as the extensive water inflow and squeezing were encountered. And the Vernia tunnel was used the permanent sprayed concrete as a single tunnel lining along with the glass fiber reinforced polymer rock bolt as the permanent rock support. So the additional sprayed concrete and glass fiber reinforced polymer rock bolts were added later to be able to cope with the requirements of the permanent support and guarantee long-term stability. So altogether, almost around 100,000 glass fiber reinforced polymer rock bolts were installed, and over the course of last 22 years, so it came to operation in 1999. So it had been 22 years since it came to the operations. The rock support has been inspected regularly, and the GFRP rock bolts are performing very well. And you can see in this figure the tunnel from where the train is passing. In the second case study, we'll talk about a project where glass fiber reinforced polymer rock belts were used to monitor internal force of the rocks surrounding a mine-sealed tunnel. So it was located in the northwest of the Pearl River Delta. The total length was approximately 2.5 kilometers. The tunnel shape is circular with a radius of approximately 3.35 meters and an average burial depth of approximately 18 meters. The tunnel transverse formations that primarily consist of lightly to fully weathered granite, a plastic hard granite residual soil layer as shown in this figure. And the environment is slightly acidic with high concentration of ammonia and nitrogen. The tunnel was construction with the sealed matter from west to east, and in 100 meters around the east terminal, the tunnel, as you can see in this figure, here we can find the lightly weathered granite layer and boulders with a rising local rock surface, which create challenges for the seal drilling. So in that case, what they did, the construction was based on the initial mine tunneling excavation, and then it was followed by seal segment. And as we can see in this figure, so the equipment used for the monitoring the internal force of the rocks surrounding a mine seal tunnel for initial support was consist of a fiber reinforced polymer bolt, which had a length of 8.2 meters, a diameter of 18 millimeters, and tensile capacity of 203 kilonewton, shear capacity of 101 kilonewton, and modulus of elasticity of 45 gigapascal. A dynamometer measures variation in the steel rings by vibrations frequency to determine the tension in the bolt induced by rock soil sliding, and the measurement of dynamometer range was 1,800 to 5,000 kilonewton with a precision of 1 kilonewton. And there was an information collection and transmission equipment, which consists of a mechanical information collecting module, a computing module, and a transmissions module. The energy supply equipment was based on a solar energy power supply system, which consists of a lithium battery and a solar panel. And based on the geological condition of the support project and requirement of the construction project, one fiber reinforced polymer rock bolt based monitoring point was used. As you can see here, the monitoring point, the vertical distance from the surface was about 20 meters, and this figure show the vertical section where the monitoring was done. The tunnel section was a circular with a radius of approximately 3.35 meters, excluding the initial support and segment. The tunnel clearance radius was approximately 3 meters, as you can see from this figure. And based on the actual operability and requirement for continuous operation without interruptions, a monitoring point, which is located here, was located at 330 degrees around the section as shown in this figure. The construction of the fiber reinforced polymer rock bolt was based on double grouting. The first was conventional grouting or the primary grouting, as shown in this figure, and the second was was the pressurized grouting with a grouting pressure of 5 to 6 megapascal. This figure shows the field deployment of monitoring point, and based on the actual requirement of the support project, the data collections frequency during the monitoring period was set to once per hour. And once the tunnel mining excavation was completed, the dynamometer was removed before the seal machine reaches the monitoring point. After that, the seal machine's cutter had cut the FRP rock bolt, and as the FRP bolt have low shear strength and is brittle in nature, so it was cut into fragments and has no impact on the sealed machine. And it is like contrary to steel rock bolts, where if you use the sealed machine over the steel rock bolt, then there will be some impact on the sealed machine. Now, why we should select SFTec rock bolts? Because they can be installed with resin categories and forced into the pre-grouted holes. And SFTec rock bolts is made of fully threaded glass fiber reinforced polymer profile for optimum mixing and bonding properties. And SFTec rock bolt can be delivered with either with glass fiber reinforced polymer, which is cuttable, or steel plates or nuts. Here you can see the glass fiber reinforced polymer plates and nuts. Now, in conclusion, the high tensile strength, relatively low shear strength, extremely low conductivity, and most importantly, corrosion resistance of fiber reinforced polymer rock bolt make it suitable for the harsh underground mines and tunnels. The fiber reinforced polymer rock bolt system provides an effective and safe method for remotely monitoring the internal mechanical behavior of rocks in a mine sealed tunnel. Finally, the corrosion resistance capability of fiber reinforced polymer rock bolt provides better serviceability compared to the steel rock bolt, which corrodes in days in harsh underground coal mines. But with FRP, it is not going to corrode. Like you can, as I saw in one of the case study, so it is still 22 years, but the tunnel is fine. It's the tunnel, the GFRP rock bolts are still working over there. So you can find the SFTec rock bolt, which is available at the SFTec as the SFT rock bolts. Thank you for your kind attention.